In this lesson, we're going to be discussing products of radicals. And I already have an example written out here, 4 times the square root of 8. And to simplify this, I'm going to start by simplifying the square root of 8. I'm assuming that it's a skill that you already have. I'm going to organize it into pairs and non-pairs. Square root of 4 times the square root of 2. Now we should know what the square root of 4 is. The square root of 4 is 2. So it's 4 times 2 times the square root of 2. Now the square root of 8 has been fully simplified, but a rational number came out, and that's 2. I need to multiply the 4 and the 2 to get 8. That gives me 8 times the square root of 2. Let's try another example. 7 times the square root of 20. Again, I'm going to have to simplify the square root of 20. And I'll kind of let the 7 follow along as I complete that process. So square root of 20 is equal to the square root of 4 times the square root of 5. Square root of 4 is equal to 2. So I substitute 2 in for the square root of 4. Square root of 5 just comes down. 7 times 2 is 14. And I get 14 times the square root of 5. Try another example. This time, let's say I have 4 times the square root of 96. Once again, simplify the square root of 96. The square root of 96 is the square root of 16 times the square root of 6. The square root of 16 is equal to 4. That's 4 times 4 times the square root of 6. 4 times 4 is 16. 16 times the square root of 6. And again, I'm going quickly through the process, but if you need to draw out the factor tree for 96, you could certainly do that. 6 times 16, 2 times 3, 4 times 4, 2 times 2, 2 times 2. And when you do that and reorganize, you end up with 4 4s and then a 2 and a 3 left over, which is how I got the square root of 16 times the square root of 6. Say I had 1/3 times the square root of 45. Well, the square root of 45 simplifies to be the square root of 9 times the square root of 5. Square root of 9 is 3, so that's 1/3 times 3 times the square root of 5. 1/3 times 3 is 1, so your final answer is just the square root of 5. Sometimes problems will involve more than one radical. For example, let's say we had 2 times the square root of 5 times 2 times the square root of 10. In a problem like this, you've got your options. Sometimes you might be able to simplify one of the radicals. In this case, I can't. Square root of 5 is fully simplified. The square root of 10 is fully simplified. So I'm going to multiply the rational number times the rational number. That's 2 times 2. That gives me 4. And I'm going to multiply the radicals, or the irrational numbers. Square root of 5 times the square root of 10. That combines to be the square root of 50. Now, while the square root of 5 and the square root of 10 by themselves couldn't be simplified, when you put them together, I get 2 factors of 5 in 50. So the square root of 50 can be simplified. Square root of 25 times the square root of 2. Square root of 25 is 5. Which gives me 20 times the square root of 2. Now this process will work the same way if I add variables to the problem. Say I had 4 times the square root of x cubed times 3 times the square root of 4x squared. Now again, I have my options. I could simplify the square root of x cubed and the square root of 4x squared, or I can multiply them together first. Whatever you feel more comfortable with. In this case, I'm going to go ahead and multiply them together first, even though that's a perfect square. And when I do that, I get 4, and if you multiply x cubed times x squared, you add your exponents. That property is x squared times x cubed. Like bases, you add your exponents. So that gives me 4 times x to the 5th. Simplify that as the square root of 4 times the square root of x to the 4th times the square root of x. And to get those numbers, I broke it apart. Square root of 4, and then square root of x to the 5th. That's not a perfect square, so I'm going to reorganize it into pairs and non-pairs. Gives me 12 times 2 times x squared times the square root of x. 24 x squared times the square root of x. Now you could have approached that problem differently and gotten the same answer. This was just one way to do it.